so this was page 58. Is that right? So top right-hand corner, page 58. And then this is going to be factoring quadratic trinomials. So you're going to have tons of room to write on all this because I'm not going to use up. I just wanted to separate it out so you could actually read your stuff. So, example 1. We're going to do something real easy, real basic. And so, just make sure example 1 stays in the whole top box, like there's my line. Okay, so example 1, we're going to do n squared minus 13n minus 48. All right, so hard question of the day. I'm looking for two numbers that multiply to give me what? 48. Right? Positive or negative? Negative 48, right? So negative 48. So if it's going to be a negative 48, are the signs on my numbers the same or different? Different, okay? So it's a plus and a minus. And then they're going to have to combine, really, which is subtract, I guess, if the signs are different depending on how you look at it, to give me a negative 13, right? So factors of 48 are what? Oh, let's think about it this way too. When I put this down, okay, we know a is 1, right? So that makes this super easy. So this is n, this is n. I know the signs on my numbers have to be different because this is negative, right? So this is going to be plus and a minus. Since this is a negative 13, which one's negative, the bigger one or the smaller one? The bigger one. So my bigger one has to be negative. Okay, does that make sense? Remember all that stuff? Okay. So your factors of 48. I mean, sometimes you just know what the two numbers are, right? Sometimes you have to actually write them down and think about it. Like just jot some down because maybe the obvious ones that you're used to don't really work. But because is it going to be 4 and 12? No, right? Is it going to be 2 and 24? No. What's it going to be? 3 and 16, right? So 3 times 16 is 48. 3 and a negative 16 gives me a negative 13. So I know my 16 is bigger. This is 3. You don't have to do anything fancy to that. That's it. The box is out. Don't draw a box for anything. We're big boys and girls. We can do that, right? You can factor that. You should be able to factor that kind of stuff in your sleep, right? Okay, so go on to the second box. This is going to be number 2. So this is the second box on the front. Oh, let me ask you another question. Let me go back up here real quick. So at this point, should I have taken both of these and set these equal to 0 to solve for n? No. 2 reasons why. What's one reason why? It doesn't ask us to solve it. It asks us to factor it. And the other one, I heard it somewhere. It's not an equation. Do you see it in the equal sign? It's not an equation. You can't solve it if it's not an equation, right? So make sure you know what's being asked of you so you don't go too far, but that you also go far enough if you were supposed to solve it. Because sometimes when you're supposed to solve it, y'all lose the equal sign and the 0, and then you just factor it and then you just think you're done. So just be careful with that. Okay, so number 2. Y squared plus 21y minus 72. Okay, I'm going to give you a minute. I want you to factor that one. It's taken some of y'all a little longer than it should. I don't think it's because you don't know how to factor. I think it's because it's not that you don't know how to factor quadratics. It's that you can't really factor the negative 72 is where your problem comes in. And one of the reasons that some of you aren't able to do it quick enough is because you don't know your multiplication tables as well as you should, right? That's something that's holding you up. Do you think on a test in here or on an AP calculus exam that you have time to spend trying to figure out what the heck multiplies to give you 72? Like that should just come to you easily and quickly to be able to break it down. The other thing that I think is stumping some of you is that you're thinking, like they're in your head and they're dancing around in your head. Write them down. If you don't just know the factors, sometimes you will, sometimes you won't. Have a methodical way to go through them, right? So let's just set this up first. I got a negative 72 that I need to multiply to give me. Excuse me. So I know that a is 1, so this is y, right? And then this is negative, which means the signs have to be different. And which one's bigger? Which one's positive? The bigger one or the smaller one? The bigger one, because that's positive 21. All right, so my factors of 72 could be 2 and what? 36. So, positive 36, negative 2. All right, well, that's not going to work, right? So does 3 go into 72? Yes. And you remember the trick for that? 2 plus 7 is 9, and so it goes in there. So this would be a negative 3 and a what? 24. Okay. Now, is that one going to work? Yes. But this is how you would go through. Let's say that one didn't work. We kept going. All right, does 4 go into 72? When you think about dividing by 4, divide it in half and divide it in half again. So if you can divide it by 2, well, if you can divide this number by 2, then you can divide it by 4, right? So it'd be negative 4, and, well, then what's half of 36? 18. Okay, is 5 going to go in there? No. Is 6 going to go in there? Yes. So it'd be negative 6 and what? 12. All right. Is 7 going to go in there? No. Is 8 going to go in there? Yes. Negative 8 and what? 9. Okay. Then once you get to this negative 8, the next number I'm going to use is 9. Well, I've already used 9, so I don't need to do that again because basically it's on that side right there. But go through each one of them and just ask yourself, because, okay, there's more than maybe there would have been for some of the others, but it's not like there's 1,000 of them. And instead of just sitting there and all you can think of is 8 times 9 and 2 times 36, like, go through them all methodically, right? So we know that this one right here is what we're going to use. So that's negative 3 and a positive 24. Okay, everybody okay with that? All right, so on the inside here, I'm going to actually get another sheet of paper since it's bleeding through. We're going to talk about when A is not 1, and we're going to look at it 2 different ways, okay, which are kind of the same, but not exactly. And one of them I can explain mathematically. The other one's kind of a shortcut that skips all the reasons why. And it uses some things that you're not usually allowed to do, so that's what worries me a little bit if you don't really understand what's going on. Okay, top left box. So this should be example 3. And since we're going to do it 2 different ways, let's see, let's actually, if I should do it this way, let's do it this way. So in this top left box, make like a squiggly line down the middle. So we'll do it one way on the left, one way on the right. Okay. So this is example 3. And we're going to do 5n squared minus 16n plus 3. All right, so if A is not 1, what should always be the first thing you look for? Greatest common factor. Is there one? No. Because if there's a greatest common factor and then A is 1, that's fantastic. Doesn't happen here, right? So then you take A and you multiply it by C, keeping the sign, and what's 5 times 3? 15. Okay, so 15 is our magic number. And then, now for 15, we're looking for 2 numbers that multiply to give me 15, and would combine to give me a negative 16. Since this is positive here, what do you know about the signs? They're the same. Now, I'm not looking for anything that multiplies to give me 3. I'm looking for something that multiplies to give me 15, and the signs are the same. They can be positive, positive, negative, negative to give me this. So what is it going to be? Negative 1 and a negative 15, right? Okay, so I can't just plug them into the parentheses like I did on the last ones. We're going to do first by grouping. Okay, I'm pretty sure you were taught by grouping. You may not have used it a lot, but one of the reasons that grouping is good and is helpful is that it will work for other things too, besides just quadratic trinomials. So we know we can split this negative 16n into negative n and negative 15. So I'm going to rewrite this as 5n squared minus n minus 15n plus 3. And then what I have here should be the same as this right here if I was to combine my like terms back, right? Everybody good? Okay, and so now I'm going to group the first 2 together, the second 2 together. And now I factor out the GCF of these. I want the first variable to always have a positive coefficient. So I want a to be 1. So I'm going to make sure here, since it's already positive, that I factor out a positive if I factor out anything. What is the GCF here? I can divide a 5n through both of these? Just n. Okay, it's what I can divide both of these first two terms by, and it's just n. So then I'm left with 5n, then what? Minus 1. Okay. Now here, this is negative, right? And so I need to factor out a negative here because I want whatever's in front of this n to be positive. So when I look at these two terms here, what's the GCF? It would be a negative 3 in this case, but 3 is what I'm looking for. So minus 3, which leaves me with 5n, and then what? Minus 1. Now when you get to this point, these two things right here should match. If they don't match, something went wrong. You have subtraction here, okay? There's no foiling stuff back together. This is multiplied by this one right here, and then this is multiplied by the negative 3. So these two terms have a common binomial factor. Make sense? Both of these, the n and the negative 3, are both multiplied by 5n minus 1. So that's your common binomial factor. So that comes out, and that is 5n minus 1. And then you're left with this right here, and it's multiplied n minus 3. That may seem to take a little bit longer, or maybe than another way you've seen it. But if you understand factoring by grouping, we can do it with cubics and some other things as well. Okay, everybody good with that? Does that look familiar? Have you at least seen it, even if you didn't do it that way? Yes or no? Yes. Okay. So here's this answer. Now let's do the exact same one. I'm going to do it a little bit differently. So I'm going to write down again 5n squared minus 16n plus 3. This is a little bit different than what Miss McWhorter does. Same kind of idea, but it's what, this is still 15. It's what Miss Rice does, and I think this kind of avoids the whole fraction thing, because didn't she show you where you would like leave the n with just n on both of them, and then you find out the two factors here, and then you divide the second term by something? Okay, so that still works. I'm not saying you have to change anything. If that totally makes sense to you and you can do it that way, that's fine. I am not going to make you change anything. I just want to show you some other things if maybe that didn't make that much sense to you. Maybe it did. Maybe that was fantastic. But so we got 15, and it's still negative 1, negative 15, right? So instead of leaving the 1 out there, leaving the 5 out there, or leaving the 5 off, because she would leave it off, right? See, I get their two ways confused too. I'm going to go ahead and do this, but instead of leaving it off, I'm going to take whatever a is originally and leave it in both of them. So this is 5n, this is 5n, and our signs were the same, so it's negative 1 and negative 15. Okay. Now, if I multiply that back together, am I going to get what I have in pink right here? No, so clearly I'm not done, right? So now I factor out the GCF of this, sort of. It's not really factoring it out because it's just going to go away, right? What's the common factor in these two? Is there one? No, so that one just stays like that. Is there a common factor here? It's 5, right? I can divide them both by 5. Those cancel out. That becomes a 3. So I get 5n minus 1 times n minus 3. You get the same answer. You should, because if you don't, then they don't work. But it's just a different way to look at it. That way you don't have to, it's the divide and slide, I think, is what the one Miss McWhorter uses is called. This is called Dirty Harry. I have no idea why. No clue. Okay. Everybody okay with that? All right. So, just by a show of hands, because I'm just curious, how many of you would prefer grouping? Okay. Just be honest. Okay. And how many of you would prefer this way specifically? Okay. How many of you would prefer Miss McWhorter's version of this? Okay. So that's fine. Both. And it's whatever makes the most sense. What you should get to, and hopefully you are getting there pretty quickly if you're not already there, is that you have all these tools in your toolbox and you decide when to use what, but you have to know what they do, that these two do the same thing, and whatever makes the most sense to you at that time is fine. Okay. But if you're not factoring out the GCF here or something weird, that's fine. You want to do it this way? I don't have a problem. You want to do guess and check? Knock yourself out, because you should be able to also get to a point where you can just kind of see some of them and just know, and you don't have to go through 1,000 steps. We want you to get to that point. But you do still need to understand grouping for other things that we do. Does that make sense? Because that's one of the things that actually Miss Bruce, she's the head of the AP one that I keep telling y'all stuff about, but that's one of the things that she said that the students overall are a little weak on, is the concept of grouping, not just for factoring, but for some other things like how you put stuff together. So it's a good idea to keep practicing that. All right, bottom left box. I'm going to let you do this one. And we'll do 3x squared minus 11x plus 6. So you factor that one however you want to factor it. I'll give you a minute to work on that. So I will kind of run through this one both ways too, just because. So this is 18, right? This is positive, so the signs are the same. And this is negative, which means it has to be negative, negative. So what are my two factors here? 9 and 2, okay? So 9 and 2 are my two factors. So I've got two options here. I can do this and say, all right, well, I'm going to have 3x and 3x. And then I know it's negative, negative, so this is 9 and 2. The reason this doesn't really have a mathematical basis to it is anytime you factor something out, it really shouldn't just disappear, right? And you're technically not factoring it out because it should have never been there. So this right here kind of is nothing. It gets you nothing. But if I factor if I divide the 3 out here, this will give me the x minus 3, and then this stays 3x minus 2. So you just have to understand, what I don't want you to get confused is that other times that you can divide things out like that or factor it out, it can't just disappear. Right? I could do it by grouping. So if I look at it as grouping, it would be 3x squared minus 9x minus 2x plus 6. Right? So I'm going to get these two together and these two together. So here I can factor out a 3x. This gives me x minus 3. Here I would factor out a negative 2, which gives me x minus 3. Remember, these should match. If they don't, that's a problem. So then I get x minus 3 out here and 3x minus 2. You find what works for you and you stick with that, and really consistency is kind of the key there. Okay, we good? All right. Let me give you another one. Number 5. I'm going to give you 6x squared plus 17x plus 12. Anybody doing like a guess and check instead of one of the methods? I mean, it's okay if you are. I'm just curious. Okay. All right, so let me give you a minute to work on that one. That dang 72 again, right? And since this is positive, the signs have to be the same. Since this is positive, it's positive, positive. If you don't just know what the factors are, you can start listing them out again. But what are the two numbers that would multiply to give me 72, add to give me 17? 9 and 8. Okay. All right, so this is the kind where the guess and check might have worked okay on the other ones, because you just had, it either 5 had to go on one of the, or two, the first one or the second one, can't go on both. Here I could have, when I actually have it factored, it could be a 6x and an x, it could be a 2x and a 3x, and so you got way more to guess and check through. So having a method is a whole lot better for sure. So when I use this, I'll go ahead and do grouping first this time. 6x squared plus 9x plus 8x, because I want to make sure you see both often, plus 12. Right? So then group those two together. What's my GCF for those two? 3x. Okay. So I'm going to get x plus 3. Now, what if you had written 8 first and then 9? Would ours look a little bit different right now? Yeah, would we get the same thing in the end? Yes, so it's fine. And then this is positive, and then the GCF here is 4. Right? So that gives me 2x plus 3. oh, shoot, this should be a 2x. Y'all didn't stop me there. 6x squared divided by 3x is 2x, and I left off my 2. And you know how I caught that? Because I went, these are supposed to be the same. That's what I was about to say, and I thought, oh, crap, mine aren't the same. It's because I left off the 2. I see what I did there? Okay. So I'm left with 2x plus 3, and then 3x plus 4. So that's option 1. Option 2 is that we leave the 6x in both of them, 6x plus 9, and then 6x plus 8. And then we just divide out whatever they have in common. Here I can divide these both by 3. Here I can divide these both by 2. So this gives me 2x plus 3 times 3x plus 4. Any questions on either one of those? You should be able to do this stuff in your sleep, right? Okay, if we need practice on it, we're going to practice on it, but you should be able to handle this. All right, one last one that's going to look a little different. 8a squared plus 22ab plus 15b squared. Give you a minute to think over that one. Because if you can do the others, it shouldn't matter what I throw in there. If it factors, you should be able to get to the same place. All right. So if I multiply these two things together, like this, up here, I multiplied 6 and 12 and got 72. What am I multiplying together here? 8 and what? 15b squared, right? This whole thing is different than that. So this is actually going to give me 120b squared. I'm looking for two numbers that are going to multiply to give me 120 and add to give me the 22b. Because see how up here I didn't care, I just think we ignored the x's, right? And so this was these two, the 9 and the 8 had to add together to give me 17x, even though we didn't put x's over here. You still got the b over here that you can't forget about, okay? So factors of 120. What's the easiest factors you can think of just looking at it? 12 and 10, right? Are those the right factors? What's 12 plus 10? 22. I mean, I can do 20 or 2 and 60. I can do 20 and 6. I can do all that, but the ones, it's usually not the real obvious ones when it's weird numbers, but it works there. Okay, so now I'll just finish this off by grouping, I guess. So I've got 8a squared plus 12ab minus 10ab plus plus 15b squared. You're not allowed to make stuff up. So I group these together. What's my GCF here? 4a. So that leaves me with 2a plus 3b. And then here, it's going to be plus, my GCF is 5b. This leaves me with 2a plus 3b, which is what we're hoping for. Right? So this gives me 2a plus 3b times 4a plus 5b. There we go. Because up here, even when we do this, you see how we do this 6 times 12, we just ignore the x's. This is x squared, x, and then x to the 0 power, basically. So here, we're just ignoring the a's, but when you ignore the a's, you still have b's. And it's okay if you don't write this over here. You just have to think about it when you put it back, what it's supposed to look like. It's all good. I'm just real quick going to do it the other way, just because, in case somebody needs to see it. So this would give me 8a plus 12. 8a plus 10. Then you divide out the common factors. So here I would divide both of these by, oh, I totally left off the b. Dang it. 12b 3b. Both of these by 4. Both of these by 2. And then that's where I get my 2a plus 3b and my 4a plus 5b. Just make sure one of the two makes sense to you and that you understand grouping even if it isn't how you would do this problem. And if you're doing the divide and slide way, that's fine too. Okay? Everybody good? All right, now grab the piece of paper that I gave you. What I had on your calendar was, you're doing page 14. That was the best way to, the page numbers are at the bottom. Oh, and you're only doing the evens, actually not all the evens even. You're doing the evens through 26. Just the evens through 26, so you can just circle those. But do them on a separate sheet of paper. Don't try and cram your work on here, all right? I want it on a separate sheet of paper that I can actually read, all right? But just evens 2 through 26. You can handle that, right? You should be able to knock that out quickly. All right, good deal. Yes? Oh, no, it's doing a 4th. Dang it. You might be able to finish in the next 10 minutes. I'm sorry. Cutting and pasting and getting interrupted, that's what happens to me in the mornings.